Yeah, afternoon, folks. This time around, I'm taking you through probability. This is a topic that you'd find normally it's after data representation in statistics as an option in A-level mathematics. I hope you find part of these explanations interesting. So let me walk you through some basic questions that I have. All right. On the screen here, we have a question, and this question is asking us to find probability of A complement, given that we know probability of A. So the idea is the probability of A complement is given by 1 minus probability of A itself. Why is that so? Because probability of A plus probability of A complement, this results in a 1. So because this part, um, this probability is known, it means this will simplify to 0.65. Right, we are moving to the second question where we have the probability of A and B, and we are told that these events are mutually exclusive. So when events are mutually exclusive, it means there is no overlap or intersection. Then in essence, we'll be saying probability of A union B, it will be given by probability of A plus probability of B, because we don't have the intersection. So I'll come and substitute here with the 0.4 and the 0.3. So this will simplify to 0.7. Right. So still proceeding to the third question, we are told that the events given here, they are independent. So if events are independent, what it implies is probability of A intersection B is the same as probability of A multiplied by probability of B. So because these probabilities are known, I'll simplify with the 0.6 multiplied by 0.2, and it looks like this will take me to 0.12. Now, we have a scenario where a card is thrown from a deck. Now we are being asked to find the face card, chance of finding face card. So when we say face card, I mean these are cards which involve images of people. So those, I think, they might be three: Q, K, and J. So if there are three in the four decks, probability of picking a face card will then be given by 4 times 3, with 3 faces from each suit, all over 52. And when we simplify here, it looks like this part will give us 1, the 13. So our final answer is going to be 3 out of 13. Then moving on, a die is rolled. Find the probability that the number picked is less than 4. So if I say probability that number that is found is less than 4, what we know is our symbol space is for a die is going to be 1, 2, 3, 4, 5, 6. Now, if a number is less than 4, it means it's 1, 2, 3. So this is going to be 3 out of the possible size of our sample space. So this will simplify to a 1 over 2. Right, so the sixth question, there's an intersection there, and we are interested in probability of A union B. So in this scenario, we will use our universal law, which says probability of A plus probability of B subtract the intersection A intersection B. So when I do my substitution, A's probability is 0.5 plus B is 0.4 minus the intersection, which is 0.1. And when I do my simplification, this will take me to 0.8. Then 2 coins are tossed. Find the probability of getting one head. So our interest is on one head. So here we would need a tree diagram. Let me change my color to blue to draw a tree diagram which will give me either head or tail. That is the first toss, or the second toss where I can even get head, tail. Even here I can get head or tail. And this will be the second toss. So if I want chance of getting only one head, it means it's either this or that. And we know that the chance here is always 1 over 2, 1 over 2, 1 over 2, 1 over 2. So chance of, for instance, getting two tails, I'll multiply these two. It will give me 1 out of 4. Now, because I want one head, I can only find one head where I have the ticks there. So probability that I'll get one head will actually be given by 1 over 4 plus 1 over 4, because each probability there gives us 1 over 4. So finally, I'll get 1 over 2 when I simplify. Then a bag has 3 red, 1 green, 5 blue balls. Find the probability that the ball is blue. Let me just take a break. I'll proceed with question 8. All right.